Hello? Can everybody hear me?
Yes.
Great. How are you guys doing? Today is the last day of the week to you guys, right? Okay. Any questions? Like, for example, regarding homework 2 or anything else? You can ask right now. We gotta wait for another few minutes so everybody can join.
Professor,
Yes.
Professor. Hi, sorry, I just wanted to talk to you. I'm having a hard time downloading SolidWorks on my computer. I'm not sure if it's my computer or what I'm doing wrong.
So what exactly is the problem?
Okay, so I just uninstalled it because I installed it the first time and I can't get it to open the 3D CAD software. It's giving me like a whole bunch of different programs like PBC and all this other stuff, but it's nothing with CAD. So I'm re-downloading it right now, and so I clicked on the website where it says College of Engineering. Uh, I should click. Is it my SolidWorks for student and faculty, right? That should be the link I should click.
I am not sure, but 1 second. So the website you're downloading SolidWorks from, is that the is this a URL I gave you, or are you just searching Google download SolidWorks?
No, it's from where did I get that from? I logged into the Cal Poly website. It's not from Google.
So it's not the link I gave you, right?
No, it's not the link.
Then you should use my link then, because I gave everybody the link to how to obtain the serial number and how to download SolidWorks. So okay, I put look at chat. That's the link, and go in there and follow the step. Download the SolidWorks 2020.
Okay, yeah, that's probably why it's not working.
Probably go somewhere else and.
Yeah. All right, perfect. Thank you.
So you guys can still hear me blowing to the mic, or it's fine right now?
Sounds good.
Okay. Cool. 24 and 6:02. I think we're good to go. Let's make today an easy day because it's your guys' Friday, right? I want you guys to have a great weekend after today. So first of all, I want to talk about something about the projects because I know we have 2 projects. The first one is a drawing project. So you guys make a drawing of a part and save that drawing in the form of PDF and submit it to Blackboard. And second project is an assembly project, which you guys gonna create a bunch of parts and assemble them into one assembly in SolidWorks and send me the assembly only. Sorry, send me the assembly and the parts only. So no drawing gonna be created in second project. And the first project, I will have a due day at November 1st. Is this due day okay with you guys? You guys have more than a month to complete it.
Sounds good.
Yeah.
Okay, because the first project should be a very easy one because you guys just need to create one part and pick that part, whatever you like, but it has to be, the actual part. And I'm gonna go over some advanced drawing technique. For example, customized datums and tolerance symbols, something like that, probably next week or next 2 weeks. And I'll make sure you guys will know everything about how to make a similar to industrial level drawing. And I will let you guys know my expectation. And here is some briefing about requirements. I'm gonna post this in Blackboard after I read this to you guys and get the feedback from you guys, because I already asked Tuesday and Wednesday's class, and this is what you got so far. And if there's no modification needed, I'll upload this right after class to Blackboard so everybody can see it from the course document. So first project, individual projects, no group log, because it's very simple, just creating one part and make the drawing very detail oriented, right? And choose any subject to draw, maybe either real or imaginary. The reason I say this is, okay, you can pick a part, because remember in syllabus, I suggest you guys to get a caliper. That's a very basic measurement tool, right? You either pick a part from anything that you're interested, and pay attention is a part. It's not going to be assembly, just one part. Or it can be imaginary. For example, you want to have some part in some movie or Star Wars and some stuff like that, and you can do that, but make that thing as much as real it could be. Don't say like okay, I made a cubic and just a square cubic, something like that, And the model should have at least 2 customized datums. And the datum I mean is machine datums. I'm gonna go over this in next week or next 2 weeks. And perhaps you guys still remember this drawing, which show in the week 1's PowerPoint. This is a machine drawing for a flange. And this is something I expect to you to have, like to turn in for me. Even though it's not in a PDF format, it is a picture, but I want this to be saved as a PDF and has much more detail. Like, look at this drawing. This drawing is very basic. This drawing has no customized datum at all. The A and B right here only represents a cross-sectional drawing and a detailed drawing. So I want to have the machine datum. For example, the middle axis can be datum A, and one of the surfaces can be datum B. That's machine datums to help machinists to secure this part. For example, this hole can be referenced to both datum A and datum B by a true position of how much offset it. And that's one of the constraints about the true position of this hole. And we're gonna go over that, don't worry about it, but that's one of the key thing I want your drawing to have. And also, this drawing should have 4 different tolerance symbols, and we're gonna go over tolerance symbols next week or in 2 weeks as well. And I mean 4 different ones. So pay attention. Somebody asked me if they can choose a very simple part, very simple configuration part, and it can be very simple. For example, you just choose a square, like a Rubik cube or something. That won't have enough detail to support that 4 different tolerance symbol, okay? Because a part must be complicated enough to support 4 different tolerance symbols. So this is gonna be a challenge one, and this is something I'm gonna pay attention to during grading. And the smallest tolerance on the drawing is 1/1000th of an inch. Don't make it smaller than 1/1000 because this is like this, I'll say industrial standard. We're not that precision. So 1/1000 is good enough. Don't make 0.00005 or something like that. All right. And English unit. So making sure I'm talking about inch is the English unit, because the standard for millimeter is 4 decimal places. That's 0.0001. All right. And the PDF. So actually, I'm expecting a PDF. So after you complete the drawing in SolidWorks, save it in PDF so you can print it. but I don't need you to print it, but just save it PDF and submit it to Blackboard. Don't submit the SolidWorks drawing file. That's gonna cost me a lot of time to open it or download it. And label material and surface finish in node section. This should be very simple, but this is requires some thinking because I want you to identify your part with appropriate material and surface finish. So for example, you're making something aerospace, so that material need to have appropriate strength. And the surface finish, if you're dealing rotating components, the rotating surface and non-rotating surface should have different surface finish. Because surface finish, if you all define it to really fine, it's costly, and no industry do that. So pretty much, if it's not rotating or is no friction related, they don't. They're gonna keep it like a standard surface finish, like 125, 63, or something like that. So any question so far? I see somebody ask, can we use a part from our final project or must be drawn and part to be separated? So it's up to you. You can do it if you think your part is complicated enough to meet this requirement. I'm fine with that.
Are we going to learn exactly what you mean by 4 different tolerance symbols?
Yeah, I will show it. Yeah, I'll show it by examples, and I'll teach you how to create it in SolidWorks. So pretty much, you would learn from very basic of what I'm talking about.
Thanks.
Yeah.
Professor,
Uh-huh.
I was wondering, so for the final project, that's what you were talking about with, we can make an engine or a block engine and stuff like that. That's what you're talking about, right?
Yeah. You're right.
All right, sorry, just want to confirm. Thanks.
Yeah, no problem. So that's the information about the drawing project. Any more questions? If not, I'm going to move to the second project.
Professor?
Mm-hmm.
So the drawing project is going to take up most of our time, or do we have like homework in between as well?
What do you mean? Like, you mean between now and November 1st, where you guys have
Yeah.
homework? Yeah, you guys will have homework.
Okay.
Because this drawing project, to be honest, this drawing project, if you, like, for example, if you were my intern, like, because I do have intern in my workplace, and they are like they're sophomores or juniors, like a year older than me, I expect an intern to finish this kind of level of drawing in 2 hours. So,
Okay.
so I think I'll give you guys 8 hours, and you guys can distribute the 8 hours through like by a month, and that shouldn't jeopardize any time for you to complete your homework.
All right. Thank you.
Yeah, no problem. Any more? All right, if no more question, if you do, just stop me anytime. No more question, let's talk about the second section. Second section is about the final project. Final project, 40% of your grade, a pretty huge one. And this one is something time consuming because you're gonna make assembly and you're gonna think about it. So I know probably half of the class gonna do the engine assembly. And I said to you guys, I'm gonna show how to do the engine assembly kind of from scratch, right? So I'll make components and assemble them together, and you guys are welcome to follow my footprint and just complete the project. So it should be a breeze for you guys who choosing the engine assembly. And for somebody else, for the rest of you guys who want the freedom to create something you like, you can do that, but you need to tell me by email, like what kind of stuff you're trying to make. And I will say it's okay or it's not. So pretty much I just need to know what you're making, because I don't want something is completely inappropriate, you know. So it can be an individual or group projects, up to you, but I'm not here to making the groups. Robotic arm, yes, I do. If you can make, like, for example, a 6.6 degree of freedom robotic arm, you're great, because I just made it a few years back when I was in school. So that's one of the idea you got approved. So, you know, if you want to commit it, then go ahead. For the assembly, can we make a move like in the presentation? Yeah, I'm gonna talk about that later. So group or individual, but I'm not gonna help you to make group. And so it's up to you. You got friends, you can group it up, but everybody in every group member need to send me an email contains the entire group name list. So I know each of the member acknowledge each other. I don't want somebody claim to be in your group and then nobody know even that guy exists. You know, I don't want any misunderstanding. So if you group up, everybody in your group send me the name list and must be consistent. All right. Each group member, oh yeah, I just went through this. Assembly shall contain at least 10 different components. All right, everybody pay attention on this. This is probably the only one very strict requirement for this project. So let's look at the SolidWorks. This is a very simple assembly I made. And it's 2 clamps. It's clamping a tube. You can see, so pretty much is, it definitely gonna be in the middle of some huge assembly or something. I just made this to show you guys the introduction of how to make an assembly. So in this assembly, question 1 is, how many different components do you guys think this one has? Type in chat, give me a number.
Including the bolts and screws?
Mm-hmm. Everything. Come on, give me a number. I see correct answer. And I see a lot of wrong answers. Sorry, I asked this in a very confusing way because I want this answer to clarify, to justify my requirement. So the correct answer is 4, because I asked how many different components this assembly has. And this assembly has 4 because the 2 clamps are duplicates and boltings are duplicates as well. And the tube, gonna be a tube, count 1. So tube and clamp and hex nut and cap screw. So total 4 different components. Exactly, duplicates and count as different components. And the reason I'm saying that is when you're making build of material or sub-assembly build of material for this assembly, you will only have 4 rows. 1 row for the tube, 1 row for the clamp, 1 row for cap screw, and 1 row for the hex nut. Okay? But next question is how many parts this assembly has. How many parts? Bingo. You got it, 11 parts. Bolting, fasteners are 8. And 2 clamps make it 10, and 2 make it 11. Why 15 though? The clamp is 1 piece actually. Yeah, maybe you're confused with clamp is multiple pieces. Yeah, and the tube is 1 piece as well. So 11 parts total because the total quantity of parts is 11, but only 4 different components. So let's get back to this list. Excuse me. I want your assembly shall contain at least 10 different components. So if you're not doing the engine assembly, this is something you need to watch. 10 different components, and fasteners doesn't count. So fasteners, like for example, cap screws, no matter what size the cap screws are, it only count one. So don't. I understand some assemblies require different sizes or different length of fasteners, but cap screws just count one and nuts count one. So stuff like that, you know, be careful when you're identify your 10 different components. And no drawing needed. So don't create drawing. Everything remain in this modeling section and assembly section. Don't create drawings. And the submission, you guys save all the parts and assembly into a folder and zip that folder and submit it to Blackboard. If Blackboard can take it, we're gonna do some experiment to see if Blackboard can take the entire folder and I can successfully unzip the folder. If not, I'm gonna give you guys an email address and email it to me. Something like that, you know? And animation is not required, but if you can make a successful animation, and I'll give you extra credit. And if your animation doesn't work, I'll just ignore it. It won't hurt you. So any questions? Oh, and it's due finals week. So when you're having your finals, and it's gonna do at that Friday. Hello?
Sounds good.
Okay. No concern at all?
No.
Makes sense.
Okay, that's good. Yeah, you guys are really good. All right, then I will save this and post this into Blackboard after the lecture. Anything else? And I believe you guys all seen this. So this one is what I download from the PowerPoint. You want to use this as a reference for basic drawing, go ahead. But this is, the detail of this one is far not enough for project one. So just remember that. But the title blocks are good. Okay, let's get into today's topic. So today is actually the third time we're meeting for SolidWorks, right? The first time I show you guys how to model things, how to model easy things. Second time I show you guys how to draw easy things. And today we're gonna assemble easy things. And next week we're gonna do advanced modeling or advanced drawing. And the week after, advanced modeling or advanced drawing. And the week after, advanced assembling. And you know, later and later, we do the engine assembly, stuff like that. So I'm gonna go like this. So today, I'm gonna show you guys how to make this assembly. All right. Is this assembly look at least familiar to you? So at least you know what this assembly is. And any question about this assembly? Or anybody doesn't even know like what it is?
Is this going to be on the test?
No, no. I just want, like when I'm talking about, for example, clamp, I want you guys to know what I'm talking about.
Yeah.
Yeah, so. Okay, let's start. No? So this class won't have any exam. We only have quiz, and 4 quiz is only 10% of your grade. And the quiz is probably, the first quiz probably gonna be next week. I'm still thinking about how to make, what to be on the quiz, because I feel like SolidWorks is, like we don't have a textbook to base on, and there's pretty much no concept. This is just like, you know, I show you guys how to do this, and I don't know how to actually quiz it. So I'm still thinking about it. Maybe I'll just merge the quiz into assignments. So give me a week, And I'll let you guys know next week. Either you guys gonna have first quiz, or I cancel the quiz section completely and make the assignment to be 30% of your grade. Because I'm thinking about the multiple choice questions, and all my potential questions are feel like so dumb. I don't know what I can ask. Yeah, exactly. So it kind of like you. So I really don't know what I can ask in multiple choice questions. Yeah, so there is a pretty big chance I'll just merge it into assignments. So everybody can be easy, right? All right, so let's get into this, and I hope we can finish quick. So before you make an assembly, definitely you're gonna have a lot of parts, right? So part, assembly, drawing, and assembly is when you have all the parts ready and you try to assemble them together, right? So let's start making the part. Oh, wow, my computer is lagging. What the hell? Alrighty, so in order to design the clamp, yeah, it does. That's why I'm thinking about upgrading my computer to 32 gig. Just lazy to do it. So at the very beginning, let's make that clamp. So in order to make the clamp, you need to know how clamp works, right? So clamp, you're gonna have two pieces to hold a tube or hold a pipe. So let's start by drawing center lines, because it's a symmetric part, right? Clamp is a symmetric shape. Left side is same as right side. So let's make a cross first, and let's make a circle. So this circle represents the outer diameter of the tube. And the radius, let's do 1.25. So we have a diameter of 2.5. All right. So we dimension it, 2.5 diameter. Everybody good with this? So this is going to be the outside diameter of the tube that the clamp is holding. So the clamp's inside diameter should be equal or larger than this 2.5. If it's smaller, then it can fit inside, right? All right, so we have the outer diameter of the tube, and now let's make the body of the clamp. So the clamp, it work in pairs, all right? One clamp can't work. We're gonna have two clamps, and that two clamps should have some space in between, because if we have this two clamp touching each other, this surface and this surface touching each other, and there is a chance this tube or piping will be slipping. So we want to apply the maximum friction it can get by the compression of the bolting. So when you're creating the body, you need to put that into your consideration. So the body, like the wings of the clamp, should have some distance between the center line. So actually the clamp, if I draw the other side, so two clamp bodies should be somehow like this. So this is the top rectangle gonna be a first clamp body, and the second rectangle should be the bottom clamp body. But we only need to draw one clamp because we can use that, in duplicates, right? So let's get rid of the second rectangle. So this gonna be your clamp body, and let's put dimensions on it. So first, how thick you want your clamp body to be? I'll say 1/2 inch. And how wide or what is the total length of a clamp? Let's do 7. All right. And how much apart you want that two clamp to be? It seems like a quarter should be fine. So these numbers are totally made up. If this clamp is failing, it must be known in stress analysis by FEA or something other method. So in this design, it's kind of like trial and error. So basically, you're designing based on your experience or somebody else's experience. So these numbers are make up and not guarantee this clamp is working. So pay attention on that. Don't say, okay, I get these numbers by calculation. No, I didn't. It just looked okay to me. All right. If this clamp, you want to test the reliability of this clamp, you need to FEA it. So let's do another circle because the clamp need an outside diameter as well. This arc is going to be the inside diameter of the clamp, which is holding the tube, right? And this one also need a thickness. So let's keep the thickness consistent with this 0.5. So 2.5 as inner diameter and 0.5 as the thickness. So they're gonna give us 3.5 in diameter as the outside diameter. All right. So 3.5 as diameter. So you can see right here, the clamp shape is here. The little like the half moon or omega shape. So start from here and the arc and it ends here. You can see it. And now let's get rid of the lines that is irrelevant. So trim, and there's a power trim, and just drag it, get rid of the lines. Alrighty, so now it looks like a clamp, right? Look fairly similar. And now let's make some minor modification. You know, we need to get rid of the sharp edge and make the, I'll say, make the tension transition a little bit more smoother. And sketch fillet. So sketch fillet in sketching right here. So you can have a fillet in sketch section. Not this feature one. The feature one also have a fillet right here. Where is that? But the feature also have a fillet, but not this one. The one in sketch called sketch fillet. All right. So you just click the first line and click the second line, and there's going to be a fillet in between. And let's set the magnitude as 0.75. And you look at the preview, how smooth that should be. It looks pretty good. Or you can change it to 0.5. It's smaller, but it also look good. So let's keep it 0.75. And you see it's way smoother. And the trim is in the sketch section right here, called trim entities. All right, so once you complete it, and you can go to feature and extrude it. And extrude it, let's make the total length as 5. So the front preview, you'll have a total length as 5 and a total width of 7. Okay. You click OK, and the clamp body is made. And what's missing now is missing holes, right? So either can go here, insert.
Professor?
Uh-huh.
Was the extrude 7 or 5 inches?
Wait, is the what?
Sorry, I didn't catch how many inches you extruded the sketch.
5, but it doesn't matter. You can just pick arbitrary ones because I did arbitrary.
Okay.
These numbers are all I made up. Okay, I didn't use any reference. So you can go insert, feature, there's simple hole. There are a whole bunch of other holes, but in this class, the simple hole should be fine. We let's stick with simple hole today, or you can search here. Let's say hole, and you'll see a whole bunch of holes right here. Let's do simple hole, and it asks you to select a surface where you want to place this hole. So definitely this one. And look, it has one direction. Go blind, go through, next surface, next, or like other stuff. We can do next surface and select a surface, or we can do through, because we're gonna do through hole, right? And this one asking what is the hole diameter. So if you're not selecting through, if you're selecting blind, they're gonna ask for how deep this hole should be. So let's do through so we don't have to punch in another parameter. The hole diameter, that's 2.5, because it seems like 0.5 should do the job, and it's not gonna thin any, it's not gonna leave too less material to the edge. So that worked for me. So one hole is made, but this hole's location is random because we just click some random place. So if you want to, I mean, you have to. So you must go under the hole. There's a sketch, and you need to add a sketch. And going to sketch, there's smart dimension, so you can identify the location of this hole from the origin to edge, or if you have other reference, you know. Oh. Oh, okay, sorry. I need to do this first. Let's do 3/4. And 3/4 as well. So now you can see this hole from blue lines to black lines. That means this hole's location is defined. You can access sketch, and now you see this hole is at one of the corner. And how to make the rest of 3, you can go exactly what we just been through, make 4 different hole features, or you can go linear pattern. So if you do pattern here, you see you have a bunch of different patterns. And since this example, okay, here's the thing. You can do that, the negative extrusion and make a hole, but that's the feature for the hole you're gonna have is gonna be an extrusion cut. So it's not gonna be a hole. And if you want to count out this hole's information, you know why there are so many different hole features right here? Simple hole, hole wizard, advanced hole, and blah, 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 like that, is because the countouts. For some model, for example, some very precision assembly, and they want to count out the hole and have the model consistent with the hole you just created. That's why you need to use these features. And for this class, we're trying to keep things simple. That's why we use simple hole. So in this class, you want to use extrusion cut to represent a hole, go ahead, because we're not going to machine anything. But later on, you'll find out sometime you only have the choice to use certain hole feature, because when you're making the drawing, you won't have very exact and precision cutouts. Yeah. Okay, so let's do linear pattern, because it goes linearly, right? So we want 1, 2, 3, 4 holes. All right, click linear pattern, we already select the whole one. So this box, it shows whole one here. If you didn't select any feature, you need to manually select the whole in here. So first question, ask for direction 1. We want this hole to have another sibling at this side of the wing, right? So let's choose this edge, because this edge goes from left to right, so kind of like, east to west. So that's gonna be our first direction, and you will see a little arrow here, the arrow pointing rightward. And that's the correct direction we desired. And this is distance, like spacing. How much apart you want this hole to be. The total length, if you don't remember, you can measure it from the evaluate tab. There's a measure. So measure this edge to this edge. It will tell you distance is 7. So 7 minus 0.75 and minus another 0.75 because we want this hole to be exact distance from the edge, same as this one. So 7 minus 3/4 minus another 3/4, that's 5.5, right? And you can see the preview lands exactly where we want. So number of instance, that means how many holes you want to create in total. In total, we want 2 holes. That's why it's 2. And this one can be 1 because if you choose 1, there's not going to be any creation here. Your original hole is count as 1. So direction 2, we want it to be downward, north, south, right? So choose this edge and look at this arrow here. It's pointing upward. That's not good. We want this hole to be downward, right? This little arrow here. So here is reverse direction, and it's pointing downward now. You reverse it back, it's upward, and click one more time, it's downward again. So how much spacing? I remember the total length of this clamp is 5, right? So 5 minus 3/4 minus another 3/4 because the edge, the origin to the edge is 3/4, right? So 5 minus 3/4 minus another 3/4, that's 3.5. And number of instance, 2, 1, 2. And it also creates 1 right here is because this and this are linked together. So this one is automatically created. So look at the preview, everything's good. And if you're interested, you can, play around with some some options right here, but it is not like is now we complete. All right, so you click on this pattern, you see 1 pink, 3 yellow. 3 yellow are the generated feature, and the pink is the original feature. Give me 1 second, let me turn on a light. Okay, any questions? Because the clamp is completely made at this point. We're not gonna, so this part is complete. All right, no question? I'm gonna move forward. So let me close this. So next, so the tube, I'm not gonna make tube is just 2 concentric circles and extrude it. So that's one very simple part. So let's make cap screws. Actually, cap screws you don't have to make because from yesterday's class, somebody really good at SolidWorks and stated that SolidWorks have a built-in database. and all standard fasteners are included. So I don't know how to access that because I don't use SolidWorks. But all the standard fasteners with standard size and standard grade, you can just obtain the model straight from SolidWorks. Okay, change the length of an extrude. Which extrude are you talking about? So, okay, before we get in the before we get in how to model cap screws, so normally the SAE standard cap screws are what I use from daily work, and it has its own dimension. Is this one? Or is this one? Yeah. Okay, so this is SAE grade 8. The one has the most strength. So from here, you can see all the dimensions are defined by the list right here. In this case, we're using 1/2 inch nominal size cap screw. So from here, it says 1/2. So pretty much this line is what we're gonna use in our case. And also, don't worry about making fasteners because commonly, if you're working, your company will have all the fasteners standardized. So, you know, by either SAE or some ASTM, something like that. I'm not expert of fasteners, but my company, like the fasteners model, we don't make that. We just grab it from the library. So today I'm gonna do a very simple model for this cap screw because I want to show you guys how to make the cosmetic thread. But just remember that you should always download the SolidWorks model or CAD model from online for standard fasteners. All right, like for example, Mastercard, and they do have the model you can download from. Or if you don't want to download and just want to do simple modeling like I'm done in this case, just follow me. So let's look some significant dimensions. So this line is what we're gonna pay attention to. So the H is like critical dimension, and F, G, and LT, and total length can vary because you can have the cap screw pretty much at multiple distance, multiple length. So let's see, F is 3/4, and G is 0.8, and LT is 1.25, and H is 5/16. So let's start sketching. So polygon, they're gonna give you the cap screws cap. What was that again? 0.866. All right, fully defined. And let's extrude it. And this one is 5/16. All right. Okay, so we finished the top part of the screw, and let's do the body. Select the surface and draw a circle. And we know the nominal size of this screw should be 0.5, so the radius should be 0.25. I extrude it. And the total length, let's make it, I'll say 1.75. because we want to make this long enough so it can extrude out the hex nut for another at least a quarter, because normally we want to leave at least a quarter clearance. All right, so this is the cap screw we just created. So we're not going to have any physical thread, because physical thread is be another feature and very complicated one. You need to use helical sweep, and if you have a lot of fasteners in your assembly, and every screw has, or every screw and nut has physical thread, your model gonna take forever to load. So people actually just use cosmetic thread. So cosmetic is kind of like, you know, makeup, right? So you can search cosmetic right here. The first one is cosmetic thread, or you can go, I believe, either insert or tool, like somewhere. Yeah, good luck finding there. But it's pretty sure it's either in insert or tool. So the first question they ask is, they want a circular edge for this cosmetic thread. The size of cap is at what I researched online for the SAE grade 8 hex cap screws. And you know, different standard will have different dimensions. And right here, the F is 3/4 and G is 0.866. All right. So the first question asks for a circular edge, definitely right here. This is where we want the thread to go, thread to begin, right? And standard, you can see NC standard, SO standard, a bunch of other standards I never heard of. And this time we use non, because I don't know which standard this one should be. And there are blind, up to next, or through, you know, stuff like that. It kind of like, if you're saying like through, you later on will have like entire thread of this body. But normally cap screws are not like that. From here you can see cap screw. The thread length is fixed. For 1/2 inch is 1.25. So we need to choose blind because we only want the thread length to be 1.25. All right, and let's get this to be 0.49, as big as possible. You can see thread cutouts, right? So this is what I'm talking about when you're making holes. The hole will have its own cutout as well. And this cutout is what's gonna show on your drawing. And definitely you can fake the cutout by typing a note, but you know, the best practice is to make the correct cutout and cut it out in the drawing. So there are more than one way to do a drawing, right? Since we're not making a drawing, so thread cutout, I don't care. So I checked it, 1.75. And you see, nothing showed up unless we created a ring. And this ring saying, oh, it's a cosmetic thread. Does it look good? It doesn't, right? We're missing the major component that we want. So why is that? So let's go to our setting. Here's option, right? Going to options, and here, let's search cosmetic. So you can see there are different cosmetic stuff, and let's click one by one to see what went wrong. So this one, allow cosmetic thread for upgrade. Okay, it's checked. All right, here, cosmetic threads is checked. Cosmetic display, yeah, it won't show. And shaded cosmetic thread is unchecked. So let's check this to see what happened. So I check the shaded cosmetic threads. I click OK. Here we go. Look pretty decent, right? Kind of just like a real cap screw. All right. Any questions so far? Alrighty. So make the nut the same way, or download the nut from some website, or just figure it out where the built-in database is in SolidWorks and use SolidWorks standard fastener. I don't know where that is. I'll figure it out if I need to. So let's close this. Let's try to assemble the whole thing. So let me open up individually. All right, pay attention. This assembly has different dimension than what I just created in front of you guys. Because this assembly was created last weekend. So, you know, when going through classes, I can't remember which dimension is exactly the same. So I will let you guys know ahead, this dimension has different, is different than what I just created. All right. So new, right? So let's move this one to assembly. Okay. So now you see the reason why I open up individual parts, so I don't have to browse, because yesterday is I have to browse every single part from the entire parts list. So let's get rid of this one. So now we have all 4 components in this section. This is what I'm talking about when you are why we only have 4 components. So you select one of that and just click in the middle of the screen. It's gonna be automatically showed up, and click again, you place it here. So you have one part you selected, placed in here. And let's insert components under assembly tab, insert components. And this list showed up again, and let's insert another clamp. There's 2 clamps, right? So you need to have a very clear idea how to install this. So pretty much, first of all, 2 clamps should be should be connected by the fasteners, right? So this surface is corresponding to this surface, and this surface corresponding to that surface, and the top surface should be kept in the same level, and the side should be kept in the same level. So let's go to mate. So same assemblies tab, and right next to insert component, there's a mate. So mate asks you to select 2 surface or 2 features to mate each other. So let's select this one and this one. And here's coincide, parallel, perpendicular, tangent, concentric, and this is distance, and this is angle. And here, mate alignment, that means direction. I don't know why I call alignment. In Creole, I just call direction. And let's flip this, because the clamps are facing each other, right? So everything is fine. You can play with those advanced mates or whatever, but it's not helping in this case. So you click OK, and another mate relationship showed up, and this one is what you just created. So let's do second pair of mating. So the top and the top, and the coincide already selected for you. That's good. And the third one is side, right? This side and this side. And now you can see this clamp is completely connected with each other. But something's wrong, right? We quit mating, and you can find all the mate relationships right here. So the first one is the inner surface, and the second one is the top surface, and third one is the side. And the colors represents different parts, orange and purple, right? You see? So this is something I'll say wrong, because we want the two clamps to be apart, not sticking with each other. So what we do, we come to here, and to figure it out which of mating relations we need to change. Apparently the first one, right? We don't want them to touching each other. So click on that, and there's the edit feature, and you went back to that interface to change the property of this mating relationship. So instead of coincide, let's do distance. And let's do 0.2, because that was my initial setting. In the new one I just created, like the one you follow me created, you should put 0.25, okay? So 0.2, you see this is much better. The two clamps are separated and waiting for fasteners to connect each other. And we can quit mating. And let's insert another components. So this time I want to do the tube. So drop it right next to the clamp or wherever you want and start mating. And make this tube, the outside surface of the tube, to be the inside surface of the clamp, and make them concentric, right? And if you don't want to make them concentric, right here, there's a distance. And distance, you can see origin to origin, or tangent to tangent, or outer tangent to outer tangent, and one outer, one inner, stuff like that. So if you make this to be 0, that's the same story as concentric, right? But I just want to show you guys, if you're dealing with two circular subjects, this is also one option to use to define distance. All right, and also, okay, let's quit now, because I want to show you guys this, because we only make one constraint, which is the outer surface and the inner surface of the clamp. So this tube, you see, it can still move. It can move freely by this direction. For like, if we say this is Z direction, so it moves freely as Z direction, and it can rotate respect to Z direction. You guys see that? And is this what we wanted? Probably not, because we want to apply a lot of friction on this pipe, right? So that means this pipe definitely should not move freely up and down. So let's do this surface, and the top surface was clamp, to have a distance of 5. The 5 is just what I made up, because it seems like is in the center, but not exactly. So this distance applied, and let's move this. It can no longer move up and down, but it can still rotate. And is this okay? It's definitely okay, even though we're applying a whole lot of friction, but this part can still rotate by, by exerting enough force, right? Or enough torque, sorry, enough torque. So, when you model your assembly and you you want this to be ready to be analyzed, so think about your constraint, because you're constraining certain degree of freedom, and you can't you must make it as as much as real you can. All right, so tube is done. Let's insert bolting. Cap screw. So cap screw is easy. The body of cap, let's do mate. Body of the cap screw going to hole, right? So go inside the hole. Let's click OK first, and you can see the bolting can go through the hole. And let's make this side of surface touching this side of surface. And now you see the bolting is in a weird position because it's direction. And let's flip this, and it's reversed. And ignore this. This is not important. So click OK. So now you can see this bolt can rotate, but can't stick out anymore. And insert the nut. And make the nut same method as a bolt. All right, and this nut can rotate freely and can't be taken out because the surface are touching is one of the constraints. Okay, so we have connect one hole, and let's do the rest of three. So the rest of three, you can follow the exact step I just showed you guys, or same story as making the hole. There is a linear pattern as well. Where is it? Oh, right here. Linear component pattern right next to mate and component preview window. So click on this because we want to save some steps, right? So I didn't select any components beforehand. So this box, components to pattern, is empty. So let's select the components we want pattern first. So two components are selected, 2 clicks. You don't need to hold anything. First direction, let's go east and west. And this is 6, even though it should be, okay, my bad. It should be 6. Look at this arrow. The arrow is pointing upward because I didn't select the edge. I select the surface. This surface is going up and down, going north and south. You can see the difference selecting the surface and the edge. So let's get rid of, let's keep it this way, all right? Because this arrow is pointing upward, it's pretty good. So let's do 3.5. And this 2. So you see the first bolting connection showed up. The preview is pretty good. And direction 2. So let's select this surface. This surface is facing east and west, right? So select that. And where the arrow here is pointing rightward, that's very good. And the distance is 6 because this clamp is in different dimension than what you're making. But somehow it doesn't go the direction we wanted. Doesn't matter. You see the preview showed up right here. Reverse it. Okay. So click OK. You have all 4 connections. Okay. Any question? So everybody is good?
Yeah.
Okay. Wow, you guys are too good. I almost can't believe it. Sure, I mean, yeah. So pretty much this concludes our today's lecture. So it just gave you a little taste in making assembly. So I don't want to make this too hard. Man, we're gonna go in a lot of details later weeks. So one thing for next week's lecture, since I might work on a project and come back home late, so next week, either I'm gonna push back the class to 7 p.m. or I'm gonna make a recording ahead and just upload it to YouTube, and you guys stay home and watch the video. So I will let you guys know by next Monday by a Blackboard announcement. So is that okay with any of you guys?
Sounds good.
Okay, thank you. Thank you guys very much for the understanding. Yeah, because I gotta secure my primary job first. Right? I'm so sorry for any inconvenience. Probably not. Probably not, because okay, let's do this. If you see a homework 3, that means there are not going to be any quiz for this class. If you see quiz 1, that means the homework number 3 will be in the future. Let me think through this weekend. Yes. So pretty much, if you have any question regarding homework 2, ask now. Or any questions regarding today's lecture, ask now. If not, you're free to go. Please have a good night.
Professor?
Yes.
So, I'm still having trouble downloading the software. Is it okay if I could share my screen with you so you can see what's going on?
Oh yeah, sure. Yeah, the recording will be uploaded before weekend, most likely Thursday night or most likely tonight or tomorrow night. Yeah, you guys all enjoy your night, and any questions, stay. And okay, before I see your screen, are you getting a warning, or you just can't get the look at my desktop? You just can't get this one.
So I can't get it says the SolidWorks ID.
The serial number?
Yeah, the serial number. So I'm running it's telling me to log in so I guess if I log in, it's gonna place the serial number in the window. But every time I log in, it says failed login. So then what I did was I pressed forgot password, and then I redid the password, and I tried it again, and then it says login fail. So then I went through
okay,
the
hold on.
Uh-huh.
Hold on. I'm gonna ask you a question. I'm not here to blame you, but how many classes do you miss? Because I went over step by step how to download SolidWorks and obtain serial number by at least first two meetings. So are you missed that 2 meetings completely?
Yeah, I did. I joined like almost the last day that I could join the class.
So when was your last day? Is it today your first day joining
No,
the
it's
Zoom?
not. No. I've been keeping up with the lectures and all of that. But just I think September 3rd was my first day. It was around there. Like I kept up with all the design stuff. I pretty much kept up with it, but I'm telling you, I'm just having a hard time with this right now.
All right. Okay. Let me show you again how to get a serial number. So do you have hold on. Do you have an engineering account?
Yeah, I do.
Okay, so you know where to go to the the EGR software, that kind of stuff, right?
Yeah.
So
I'm
you're definitely familiar with this page, right?
yes, I am.
Okay. All right. Have you seen this page?
Yes.
Wait, you have seen this page?
Yes, I have.
Then you already have your serial number. This page is your serial number information page.
Oh, I'm sorry.
Look at the SolidWorks and look at the fourth line.
Yeah.
SolidWorks CAT serial number and 90 starting with 9020. That number is their serial number. So
Okay,
if you
for
know where to
yeah,
access this, you already have a serial number, and you don't
yes.
need to log into SolidWorks. Like this,
Okay, yeah.
like for example, look at my SolidWorks. I didn't log in. I didn't log in at all. So you don't need to log in to activate it. You just need to activate through activate by internet and input your serial number starting with 9020, and then
Okay.
you should get your SolidWorks.
Okay, yeah, cool. Yeah, I'm just driving myself crazy. Like I I guess I try to just go too fast and I missed that step. Okay, thank you. Sorry about that.
Mhm.
Professor, I have a question.
Yeah.
Yeah, I have a problem like saving the parts. I don't know where the files are going. So is it possible to share my screen and show you what I get every time I need to save the files, like the parts?
Give me a second. So are you talking about you can't reopen it after you save it?
Yeah, yeah. So I made it like a specific
Okay.
folder.
So
Yeah.
go into your SolidWorks folder and there's the saves, and the default path is there. Unless you change your default, I believe
Yeah,
you haven't.
I did. I think I made like a folder for the homeworks and the labs, and that's where I'm saving the
Then you
parts.
just then you just save as and create a new location then. So you know this look at my screen, the save button, there's the drop down, and you just save as, even though you already saved this part, and you just click the first one, save as, and you can just redirect your path.
Oh, okay. So I have to go to the SolidWorks folder.
No, you don't have to go SolidWorks folder. I mean, if you already have the parts open,
Yeah.
you just save as into a different location.
Yeah, when I save it like as the folder that I did, that I made.
And what's the
Yeah.
problem?
Yeah, when I open it back, like I have a problem like opening the part back.
So it gave you a warning.
Yeah, it shows like file not found.
Are you talking about a part or
Yeah,
assembly?
a part.
A part?
Yeah.
Okay, let me see. How can I give you? I think you can share a screen now because I said multiple participants can share simultaneously.
So I get this file not found.
Okay, go to the open button. Don't go recent documents. Go to the open. Click that. Go to the folder. You save your parts.
Yeah, here.
Now open it. Choose one and open it. Man, your computer is slower than mine.
I know.
Are you using a laptop?
Yeah.
Okay. Wow.
Yeah.
Man, good luck with your project. Yeah, you see it?
All right, thank you so much.
Mhm.
Thank you.
Yeah, no problem.
Have a good night.
You too.
Thank you.
Anybody else? Yeah, thank you. Have a good weekend too. If there's no more question, I'm gonna bounce and email me. If you,
Professor,
yeah.
just a quick question for you.
Yeah.
So you say you have like an engineering job, right?
Mhm.
So you got so just a question for you, how like I'm just wondering like how was it easy after college or school getting your first job and stuff like that?
I'm not sure. I mean, I got the job pretty smoothly. I'm not
really?
sure. Yeah, I got it right after the school.
All right, cool. Okay,
But
forget
I
you
mean,
talking
it's not my dream job. But I mean, at least it's an engineering job.
Right. Yeah. No, that's pretty cool. Cool. Good to know.
Yeah, just do your
All right,
best, man. Yeah.
All right, Professor. Have a good one.
You too. Have a good weekend. Okay. Actually, the homework one has no right or wrong format at all. Tyler, is that your name? Let's see. Tyler, sorry, you. Wait, are you talking about homework one or homework two? Homework one. Wait, why is all this homework two? Wait, did you submit it back to homework one? Because every time I open up homework one, it shows the 12 pages stuff. Tyler? You submitted the wrong thing. You did homework two, but you submitted back to homework one. Hello, you still there? Hello? Yeah. So the homework one, I'm not. I think you submit your homework two to homework one, and I don't see your homework one there. Yeah, there's only one attempt. Hello? Well, anyway, if you can hear me, then do your homework one and submit your homework one back to homework one so it can cover your homework two attempt, and then resubmit your homework two under homework two. All right? What do you mean you checked in homework one? Can you talk? Oh, I'm sorry. Okay, I totally confused. Okay. Okay, I see. Oh, this is a homework one. Okay, don't worry about it. You're good. Yeah, because I never expect somebody do homework one in SolidWorks. I thought you were doing homework two, because homework two you can either do by hand or by SolidWorks. Homework one is mix and match. You know, the homework one seriously is like, for example, the first one is matching with K. and second one is matching with D or something. You know, you're just supposed to, Word doc or in Notepad saying first one K, second one B, third one J or something like that. you did way more than what I asked. Yeah, you see, this one is matching views. No, you're great. You're great. You did very good. The SolidWorks stuff is really time consuming and challenging, and I'm pretty sure you already you have a pretty good foundation now. All right, man. I mean, if you want to do homework too easier, just draw by hand. And I don't mind show you guys show you a little bit of homework 2 solution. This is what I'm gonna post today anyway. So you see the homework solution is just like this. You can just draw by hand on an engineering paper or on white paper, stuff like that. Yeah, I thought only some people doing homework 2 by SolidWorks, but anyway, you get it, right? Yeah, if you like to, you can do it on SolidWorks and submit the same way. Yeah, just because somebody wants some challenge and asked me if they can do homework 2 on SolidWorks, I say yes. So you definitely have the option, but either way, won't hurt you. Yeah, homework 1 is okay, man. It's totally 100%. All right. So you have a good night. Alrighty, bye.